Hi, I'm Abby, and this is lab number 2, Lines of Charge. The purpose of this lab was to continue using ideas that were presented in lab 1, but to see the difference in results when the tapes were treated as line charges as opposed to point charges like they were in lab 1. The overall results showed that the tapes have the same charge, resulting in repulsion when they are close. As a point charge, the electric charge on a piece of tape is around 1.35 times 10 to the negative 8th coulombs, and as a line charge, the electric charge on a piece of tape is 2.56 times 10 to the negative 8th coulombs. The experiment for this lab was the same as lab 1, in which charged tapes were created by ripping apart clear pieces of tape that were stacked on top of each other. The two pieces of tape repel each other, so you can find the distance between the floating tapes, and you can calculate the charge from the model and gravitational force. In this lab, we assumed that there is no air resistance and that each tape is treated as a line charge as opposed to point charges as they were in lab 1. The fundamental principles used in this lab was the equation for an electric field, electric force, gravitational force, and the fact that the upper tape is in equilibrium, so the net force equals 0. To find the electric field for a distributed charge, you can divide the charged object into a series of point charges, find the electric field of a typical piece, sum the electric field of all the pieces to find the charge, and use the superposition principle. Here's the data and measurements for the lab, which is what I used as the initial conditions in my GlowScript code. The mass of the tape was 0.0002 kilograms, the length was 0.2 meters, the width was 0.02 meters, the distance between the two pieces of tape was 0.029 meters, the force of gravity was 0.001962 meters per second squared, and the estimated charge on a piece of tape was 2.1279 times 10 to the negative 8th coulombs. This system was the upper tape, and the surroundings were the lower tape and everything else, including Earth. The calculations for this lab are as follows. I was able to equate the force of gravity to electric force because the net force on the upper tape was equal to 0 because it was not moving. So, since the force of gravity was negative 0.001962 newtons, the electric force was 0.001962 newtons in the positive direction. The line of charge Q was represented by 10 point charges dQ. I used the GlowScript code to create iterations of electric field and electric force calculations for each dQ. I displayed the superposition of electric force as an arrow opposite gravitational force arrow, and then I guessed and checked the total Q values so that electric force equaled gravitational force for the approximate charge of tape. Here I have my GlowScript code. I have the initial conditions and constants, so I have gravity, 1 over 4 pi epsilon naught, the mass of one piece of tape, the distance between the tapes, and the estimated net charge on one tape, which I found by trial and error, and down here I have the function to calculate electric field. In this part of my code, I have a function for forming a line of distributed charges up here, and down here I have the code for creating the lines of charge representing each piece of tape. And in the final part of my GlowScript, I have a section that iteratively calculates the electric field and electric force from each point charge dQ, and I have this part that creates arrows representing the electric force and gravitational force values pointing from the middle of the upper tape. This is what my GlowScript code looked like when I ran it. The white arrow equals the electric force from bottom tape on top tape, the yellow arrow is the force of gravity on the top tape, the green arrows are the electric field of each dQ of bottom tape at the location of the top tape, and the magnitude of the electric force equals gravitational force. And you can see down here that the magnitudes are equal, and the electric force I calculated had the estimated value of my tape charge right here. So some similarities and differences include the fact that the force of gravity and electric force are equal and opposite in both experiments. However, Lab 1 modeled the tapes as point charges, but Lab 2 modeled the tapes as lines of charges. A possible source of error could have been that the charge may not have been completely accurate on the tape due to humidity and human error. What if I had modeled each of my tapes as a single point charge like in the previous lab? So, in the previous lab, I calculated that my point charge was 1.35 times 10 to the negative 8th coulombs, but in this lab, with a line charge, it was 2.1279 times 10 to the negative 8th coulombs. The line charge value was 1.57 times greater than the point charge value. So, why do these estimates differ, and which value is more likely to be closer to the real value, and why? So point charge estimates have all the charge coming from a single point at an observation location, but line charge estimates have the charge distributed over the line and sums the electric fields from each of these points at the observation location. The line charge model is more likely to be closer to real value because it has a better representation of the tape. The line charge is also a superposition that gets closer to the actual value with more small pieces until taking an integral with infinitely small pieces. In conclusion, we can use Newton's second law and Coulomb's law to calculate electric charge and electric force. The line charge model is more precise because it better reflects the actual shape of the pieces of tape. And the computational models make it easier to visualize and calculate the effects of multiple electric fields from each subpiece of the object.